What if your home assistant smart home could automatically recognize your face and unlock your door, all running 100% locally? Welcome back to Cyber with Kraj. Today we are building a real-time biometric authentication pipeline by training our face using embedding model. RFace maps a facial feature onto a multi-dimensional sphere, converting my face into unique 512 dimensional vector. This means it still recognizes me even with changing lights, angles, or glasses. Also, I'll be comparing with vector embedding in two-dimensional by using few examples. Our local vector database compares that vector using cosine similarity in sub-milliseconds. When score passes our security threshold, a REST API call triggers Home Assistant to unlock the door. In this video, we are going to build a very simple piece of this pipeline step by step on our local dev machine, from webcam capturing to API automation. Let's jump over the code and get started.
So I created this documentation all a view of how the inside faces works here, and this is the actual flow diagram. But before that, you need to understand what is a vector embedding. So all the LLM, right, based designed on the foundation embedding, because embedding is nothing but an list of collection of data, and they map according to the closest closest meaning. Okay, so let me open this page, because you need to know what is the basic of vector embedding. And this website, I like it because they have a quick overview of what is a LLM, how the LLM is works. As I mentioned, LLM is it's foundation for generative AI, but before LLM comes, right, there is something called embedding. After embedding only, they created this something called large language model, which is extractor from the embedding, because they added attention mechanism so that it can able to align the word based on the meaning, right? But for the video sake, what I'll do, like I'll quickly go to the vector embedding section here, and let me show you the picture. So this is how the embedding works. Let's say king, man, woman. So these are all resembles to the human, so that if you see, right, all the values will be very close, 4 5 3 3.5 5 3. So if you see, right, all this it's a two dimensional vector. If you see the alignment, right, very close. Let's say apple, banana, orange, these aligns very close in the two dimensional vector, because all belongs to an fruit category. And football, golf, tennis, these are all comes under games, and all this categorized in -3 -2 -2. So if you see based on the color code, right, the two dimensional vector, it's aligned. So let's say if I type king, if I click space, and automatically man will pop up, because king and man are very close to each other. So that's how the embedding works. It will try to align based on how we train the data, right, with the data set, how we are trying to train them and how we are closely aligning, right. Similar to that, this face embedding also works. Let me go back to my previous screen. So in this flow, if you see, there is a flow chart. So in this flow chart, here you see I'm recording a video which can be MP4 on any format. So I'm recording in my phone, and I'm just capturing my video by rotating my face so that it will capture all my face dimension, and I'm converting those videos into frames. So let's say each second I have 60 frames, so that I can capture some few samples of those frames randomly, or let's say every 3 second, I'll be picking one frame from the video, and with that frame I'll be trying to capture my face. So let's say like currently my face getting detected, and all these frames it will try to make sure my face is getting detected. And once face is getting detected, each frames it's marking those 5 dots. So what it does is let me bring back my uh, uh, pen here so that I can draw you out the flow. So let's say from this nose, what is the length, and from here what is the length, and from this what is the length. So it trying to measure all this distance between my nose eyes, and from left eye to right eye, what is the distance from my mouth to eye, what is the distance. Or every calculation it's making, and it's trying to create some numbers. And those numbers, right, as I explained you in my previous video, all are capturing as a vector, right? So it's a 512 dimension vector. So in my previous video, I showed you those sample like a king, queen, men. Then there's fruits like apple, oranges. Oops. Apple, oranges, then I'm not sure, banana. So all are categorizing and all are marking in the oops. So all are marking in the vector, two-dimensional vector, 2D vector. But here like, you say like 312 dimension vector, which mean there will be a XY axis, and there will be X comma, Y comma, Z comma. So keeps on. So this vector is keeps on expanding. So it's like very high value of a dimension. This is what they will call it as a neural link, where each pointers or nodes talk to interrelated to each other. Here we are using 512. Similarly, I think GPT is using I believe thousand, more than thousand dimension. So just imagine how big the size of those data, the vector data. So this is how it calculating. So once it calculated, it's creating the vector embedding, and it's storing those vector embedding in some database here, like a pkl. And this pkl, later I'm giving some name. Let's say I recorded with my face, so I'm just tagging this vector with the name kasi, so that next time when my face getting identified, it will detect, okay, this is the kasi. So I'm labeling my face in that pkl file. And the once the embedding is done, pkl file, now let's say if I'm trying to on my webcam, and if I'm trying to show my face, it can able to detect. So it used to send some feed to this model, and model will be giving, let's say, x comma y comma, like a lot of vector values, so 4 comma 3 comma 2 comma, right? When my webcam will try to send this model, and it will calculate this value, and whatever file it's stored, right, it will try to compare whether it matches 4 comma 3 comma 2 comma, like 1 comma. So in this case, it the matching almost close to this value. So it return the cosine value, which mean maximum cosine value is 1, and anything closest to 1, right, it will be considered as a very accurate data, so that I can authenticate as true. So I'll be putting some parameter, let's say it should be zero point 0.6 or a zero point 0.6 value, so that any numbers in between zero point 0.6 and between zero point 0.6 and 1, right, this will mark as my face as Kasia K. Raj. So it will detect my face, and based on this value, I'll be authenticating. So this is how the flow goes. This is a file structure I created as extension IPYNB. It's a notebook format, so that I can explain you each and every step how the flow works. And video to frames.py. So this is a Python file where I'll be converting videos into frames, and I'll be extracting the samples from those frames, which I'll be using in the coming steps to train the model and converts to the PKL format. And the video is the one I'll be storing those recorded video, the face recorded video under this folder. And later I'll be running some sample faces so that it can able to compare with this model and try to identify the pattern and return me the cosine similarity, which is less than 1, right? Between zero point 0.6 to 1, it matches as true. If below the zero point 0.6, it matches as false. So these are all the function call face analysis where I'm passing the model, and I'm selecting the what all the models allow: detection and recognition. So detection here it's using det underscore 10g dot onnx. So this file extension mostly used to detect the face in the picture, and recognition is something like it trying to recognize the distance between those face parts like eye, nose, as I explained in my video. And embedding is the one, once all the frames been extracted, it creates a list of vector and it stores under this value. And later I'll be tagging those embedding to my name, so that when I'm trying to run some sample, it try to compare with this embedding vector and trying to return the value as my name. So here you see, right, sample, I tagged this embedding vector value to Kraj. So if any sample matching with this vector, it will tag me as Kraj. If let's say if Alice face been uh, captured, and I try to extract the embedding from there, and if I show the Alice sample picture, it will try to recognize as Alice. And this is a question similarity I was explaining. So all this sample comparison, it will try to return the cosine value. There's a math actually. Later, if time permits, I'll try to show you what is that exact math value for this, and it will return less than one value. So the value between zero point 0.6 or 7 and 0.95, the person matches. If it's less than zero point 0.5, then it's a different people. So yeah. Okay. And I'm trying to detect how many webcam attached to the device, and trying to identify the face. And once been value been identified, if it's 1.0, it mark as true and label as Keraj. If not, it will mark as false, and it will return me null value here. And let's say if face matches with Alice, then it will return the label Alice and authenticate as true. So okay, let me show you the my lab. Um, Okay, so this is a Python file. It's a notebook format. It's inside face.py IPYNB file. So in this, using this file, I can able to run command step by step, and I can capture the output in each cell. So these called as cells, cell 1, cell 2, right? So each cells I can execute and able to get the output in my next line. Say for example, if I run this, here you see, right, I'm getting the get user info output, and if I hover the mouse, I can able to see this values too. This is a file video to frame.py. So this file normally it read the raw MP4 file and it converts that file into frame. From that frame, it will try to pick some samples. So this is a video I recorded. So it's a 3 minutes video, and this video recorded in 30 frames per second. So totally it should be like close to uh, somewhere around 90 to 100 frames, close to. But yeah, once we execute the file, we'll come to know how many frames totally and how many frames I took the sample. Okay, and this is the path where I'm be saving the output of those frames, and I'll be using some picture to compare. Let's say once the frames been uh, collected, I'll be comparing those trained model with those frames with this sample phase and trying to extract the value, which the cosine value, which is 0.621 is the closest to match, and less than zero point 0.6 it's no match. Okay, yeah, let me go back to this file. And the output, as I mentioned, all the frames stored under this image frames output, and compare frame is the folder where I'll be comparing some images. Okay, and yeah, let me execute this. Okay, so yeah, so the file got executed, and if you see, okay, no, not this. First I'm trying to read the path of the video, then I'm calculating the dimension of those videos, so that when the frames getting created, right, the frames also will be in the same dimension. And this is the output of the frames. There is a 30 frames per second, and totally the frame count is 117, which is 30 into 3 seconds, right, which is close to 90. But again, the video can be 3.12, so there's some kind of microseconds, right? So that's also getting added here. So totally it comes to 117. Okay, let me execute this now. If you see, right, so 30 frames per second, and total is 117 frames, and every 15 frames I'm extracting one sample frame, so that I can able to capture all my face in a different angle, so that whenever I'm rotating my face while trying to validate my face authentication, right, it can able to identify this is me. Okay, so now we're going to uh, run the actual inside phase. So here the package I'm using NVIDIA. Let's say if I don't have NVIDIA, right, it will be fall back to CPU. So the CPU will try to run this phase analysis. Let me execute this. So normally it's better to use a built-in graphics card, so that any video rendering, right? So you need some built-in graphics card to have a faster processing time. And this is a quick note. As I mentioned, there's a value called CTX underscore ID. If it's zero, it uses GPU. If it's -1, it uses the CPU. And I'll be using the model detection recognition, right? And there is a other model also which I won't be using. For example, there's a age gender. So based on the picture, it can able to detect how much age this user is and what is the gender. It's a male or female. So it can able to detect those parameter also. But we are want to make sure my face is matching. So I'm using detection and recognition, right? Okay, and I'm using the Buffalo underscore L model. and I'm using ONNX runtime. So in my last clip, I haven't explained the ONX runtime. So mostly once runtime is done, it's an inference so that I can able to communicate the model. So inference is nothing but the channel where I can try to communicate to the model via API or any other IO operation, right? I can able to perform to the model. So here you can use Onyx runtime CPU and Onyx runtime GPU if you have a GPU in it. Okay, so this is where I'll be passing the frames through this inference to the GPU or CPU. Okay, now I'm initiating the face analysis. I'm loading the model. Let's see any spike. Yep, it loaded it. Let me run the next command. So this step 3 is nothing but it has a few parameters: B box, KPS, embedding, death score. Okay, so mostly we'll be using first three feature. BB box is the face bounding box. So you would have seen the screenshot in my last section where like if face is detected, it puts some boxes around the face so that I'm able to categorize this as a face. Okay, and another thing I forgot to explain you like. So here what we are doing, it's like training the model and we are trying to identify the face. Okay, so like in the machine learning world, there is a supervised unsupervised learning, right? But here if you see, right, we are not doing any labeling because we have thousands of faces. I can't add those faces and tag all those faces. Oh, this is Alice and this is John, so I can't keep on tagging the face and naming them, right? So here what I'll do, I'll be automatically using this model so that it automatically detects the face and it can tag that face, who that faces belong. So everything will be tagged or like labeled based on the pre-trained, based on the already pre-trained model which I'm using here, which is a Buffalo underscore L. And it can what it does, it detects the face and it mark in the 512 dimension vector, which is the ArcFace I'm using as a vector database. And KPS is a 5-point landmark. So in my previous section I showed you like how those dots been pointed in your face, right, so that you can able to measure the distance between your eyes, nose, mouth, right? So that it can able to calculate the actual face identification for the unique user. Okay, let me execute. And this we are not using because age sex something like we are not using here for now. But det underscore score we are using, which is 520 comma 520. Okay, it found the 8 frames, and all the 8 frames want to make sure the face is captured in those frames. That's the purpose of the find the face and box it. Okay, now we need to make sure we are detecting those face with the box, right? So let me execute this. Now in this code, right, I'm collecting all the sample and that I'm picking one sample and which face has a more than eye accuracy, more than 0.81. This is a cosine value I'm detecting. So this has more points because it can able to capture all my face. So here you see, right, it has a sorry, 5 dots. So it measuring the angle and everything. And this is a B box value, and this frames B box value, and this is a vector. So this is what I was explaining, right? It is a 512 dimension. Here you see, right? This matrix, right? It has a very big value. It keeps on going. I can't, if I expand, right? My whole screen get filled up with this value. But this is a value, it's getting filled up so that any value matches, right, it will identify this is the this picture has a human face in it. So that's where it trying to match to the closest value. Okay, so now let me execute this. I collected the face and I created a vector value for all these frames, and I'm trying to create a whatever vector I collected, right? I'm creating a .pkl package. It's like a zip file. It's like what I'm doing, I'm using the model, I'm fine tuning that with my face, so that next time if I'm trying to put my picture, right, it can able to see, okay, this is the face belongs to Kraj, alias John. So it's like a technically, like it's like a fine tuning the model. So whatever picture you extracted, right, I'm adding that vector on top of the model. So
Also, this you can say like embedding, so that whatever frames we captured and try to render the frame using Buffalo built into model, right? So whatever trained data coming from that Buffalo model, we call it as a embedding. Let me start executing step 5.1. So now we have an embedding created for my face. Now what I'm doing, I'm tagging my name over those embedding, so that it can save it as my name in the embedding gallery. So let's say tomorrow, like I have one more person which I'm doing a face scan. I can tag that face also. I can name that users in that PKL. So it's like a labeling. Let's say I want to train one model and I need to label the data what I trained with, right? Let's say I'm scanning a image which have some fruits which has a banana. So next time if I show the banana to the camera, it can able to recognize, okay, this is a banana or the orange or the apple. So similar to that, like whatever the picture I've been trained or like vectorized or call it as embedding, I can use those embedding again to recognize what this picture is. Next time if I show that picture, it can able to recognize the picture based on the tag or labeled item. Okay, so here I'm giving the path where the gallery should be saved. So it converts the embedding into .pkl file and labeling the data. So let me run the this step. Okay, so now I ran it. So it tagged the user for the embedding, right, which we vectorize the image. Now then I'm loading the gallery, so it creating the file. In that file, whatever I loaded, I'm reading the gallery and trying to see how many vectors embedded into that. So let's say currently one person is there, which is a Kraj, which is my face. Now let me execute step number 6. So in this section, we're going to compare two frame. Whatever video which we recorded and created a multiple frame, I'll be comparing the frame 0 and frame 1. I'm trying to return the cosine value. So here the cosine value maximum is 1. So whichever closest to 1 as identified as a perfect match. Okay, let me execute this. So here you see I compared 0, frame 0 and frame 1, and it returned to me 0.8148, which is close to 1, right? So it matches both the frames. So now what I'm trying to do, I'm trying to compare the frame, and I'm going to compare with the random user. So this random user I saved under this compare frames. So I'll be comparing this face and try to identify what is a match value. As I mentioned, closest to one matches us, right? But here it's a different face, so I should get a value which is less than zero point 0.5. So I put zero point 0.5 as a threshold, so that let's say if value is less than zero point 0.5, it will update the label as no match. If the value is more than zero point 0.5, it will update as a match. Let me execute this step 6.1 now. Okay, so I executed the 6.1 step, and I have identified, okay, so value is coming as 0.01, which is very less than zero point 0.1, right? I think it went to minus 0.0391. So there is no match, zero match, and it's updating as a no match. Okay, next let's execute the step 7. So in the step 7, we are going to test actual authentication using the video feed. So right now I'm using PC webcam. In future I'll be using the some camera which I'll be connecting to some small hardware in the future. That video also I'm planning to create, but for now I'm using webcam for the proof of concept, so that I can able to make sure how it works, right? So that I can embed into any devices, right? Home assistant devices. So yeah, so now what I'm doing is I'm using the Python library OpenCV. So this is a package. So what happens using this package, it's try to access any camera connected device through USB or through any other IO connected to your laptop or PC or any system, right? So it can able to detect the camera, and it opens the camera feed. It can start recording. Okay, so that's what this library is doing. So let me execute this. And another note is, for Mac it works differently, for Windows it works differently. But in future when we are running in Home Assistant, you need a Linux box. So in this case, the code may differ, but I created only for the Windows and Mac. In future I'll be adding to Linux, so that I can actually connect to the smart home assistant running the Linux. We'll try to list out all the cameras, and I need to pick which camera I need to use for face authentication. Let me go ahead and execute this cell. Okay, it's trying to recognize the camera. Okay, so as I mentioned, there is three camera it listed down, and all this camera, it's also I'm putting a logic whether it has a grayscale enabled. So grayscale enabled means some camera it will work with the night vision, right? You would have seen some camera where like you'll see black and white, because it can able to identify the actual contrast in the picture, so that it can able to detect the perfect images, the contrast, so it can able to detect the object. But the camera which I'm using doesn't have grayscale, so it showing as false, but it has a IR inbuilt. Why IR inbuilt is because for Windows Hello, right, minimum requirement is you need to have a IR camera with a good resolution, so that in low light, right, the IR light will flash the light on your face, so that it can illuminate your face to the camera lens, so that it can able to identify in your low light. Let's say if I'm walking into an house in the doorbell camera, right, and the light is not there during the night time when I'm trying to enter the house, right, this IR can able to uh, flash the light, and I can able to detect my face, and it can able to authenticate my face. Okay, okay, so now I am checking the IR is working or not. And again, no IR cameras detected, falling back to the normal camera, which mean it trying to use a normal camera with whatever light, the ambient light which I have in this room. So it uses, and I did the research on this, and what I identified is if you are using Windows, and if you are using Windows Hello connected camera, there is a lock in your registry where you are not supposed to pull the IR camera any of your application, because let's say if I'm trying to install some malware, that malware can able to uses my IR camera, and it can able to trick me to bypass the Windows Hello login. So natively what they did, Windows, right, they blocked IR camera to be detected in the Windows Hello attached camera. We can override it, but I don't want to do that, because it may compromises in my system in the future, and right now it's better not to enable, so let it be as it is for now. So what I'll do, like I won't use IR camera. I added some light source here, at least to detect my face, right? So I'm not using IR sensor here for now for this demo. Okay, next let me execute. So here is the threshold I'm putting. So why I'm putting 0.5 is because, as I mentioned, currently I'm recording in the night time, so my room light is somewhat low. So I'm putting as 0.5 in the middle, but the good number is like anything about zero point 0.6 will be good number, or zero point 0.7, zero point 0.8, right? And process NV is runtime, so let's say you can able to capture the video very smoothly, right? There is some function where I'm trying to enhance the low light so that it can add some contrast or some kind of a lighting effect when the video is turned on. Trying to compare and see which is the best match. Okay, so I'm loading all the required fields. Okay, now I'm trying to see IR live camera for try to sense my face, right? It need this function, because it will check my IR is on. If not, it will fall back to the actual normal camera. Okay, so now let me execute this cell, and here you see, right, it opened, and what you are seeing is a now live capture. And you see, right, now the inside face trying to box my face, and it's showing green. And if I try to hold my hand, right, it may uh, show unknown, right? I can show some, so let's say, yeah, it's showing unknown. So let's say if someone person, right, if I try to bring them, it will show unknown as a user. So now you see, right, the number is keep on changing here, right, which mean most of the times whenever I'm rotating the face, right, the value is more than 0.6. That's where I said the threshold. But if I add more lights into this room, right, the number may increase to more than 0.8, so that it will have a stronger authentication. That's something we can enhance, because the camera which I'm using is 1080. I'm not sure if I use a 2K or 4K sensor in that camera, it can have a better resolution. And another thing is the IR which I'm using, it's locked to Windows. Now maybe if I connect the same camera to the Linux machine, right, I don't think so they have any type of policy to block the IR camera to detect in the system, because Linux doesn't have a Windows Hello, and I think so they have any type of passwordless based authentication, because Windows Hello is mostly used for passwordless, where it detects your thumbprint or face based on the IR thumbprint, based on the your fingerprint, right? It takes some picture, it try to do some algorithm on that. So for this use cases, right, I'm using the Windows Hello camera. I'm trying to capture and trying to calculate my points. So how it's detected is based on the model which I trained my face, the video which I recorded, that's how it's capturing. the face whenever I'm rotating, right? Okay. Let me close this. If I press Q, it will be closing it. Okay. And I'm just printing the what is the resolution of the video which I did. So when I'm trying to authenticate my face, it should have consecutive 3 frames should match above the threshold 0.5. Let's say for a second it capturing 30 frames. So first frame and the second frame, all these 3 frames should have zero point 0.5 and above the cosine value will make as a authenticated. Let's say this is something sample I'm showing, but actual video I'm capturing, right? That's where the actual frames comes in. But let's say frame 1, frame 0 said like 0.6, it will make as strike 1. And let's say frame 2, frame 1 it said okay, the value is less than 0.5, it will the strike will reset to 0 again. Now it will try to check from frame 2, 3, 4, all these 3 frames, consecutive 3 frames should match. It doesn't mean like I should first first matching is this and second matching is this, right? This is invalid. So all the consecutive frame should match. So any frames it capture consecutively, then only it will authenticate my face as true. And as I mentioned, right, to have a more liveness check, right, IR should be good, but for now IR is not enabled. So but still it's authenticate clearly. Okay, let me execute this step, and it's opening my camera. Yep, it asked me to look at the camera, which I looked at it, and it can able to identify, okay, this is a KRaj, and the score value, cosine score value 0.74, which is very strong number. As I mentioned, the threshold is 5, and it's 0.75. I think the consecutive 3 frames it captured in a second, right? It all 3 matches, because why I'm saying is 0.2 second, right? Which mean it's like within 200 millisecond, it can, let's say it can capture like 5 frames. For 1 second is 30 frames, is 0.23 means, let's say it captured around 5 frames. In that 5 frame, 3 frames consecutive got matched. So that's why I'm thinking how fast it authenticated, right? And the video capturing which I'm using through NVIDIA, so again that will be more faster way of authenticating. So it's authenticated, and let's say if it's authenticated, right, I'm marking this value as true, and I'm labeling as kraj, and I'm putting this parameter so that I can pass this to downstream app. Let's say I can pass this information to some kind of authentication server, right? In this case I can use any WAT server and try to trust this and generate a JOT token, which I can able to use to the further down the authentication. But in this video, I won't be doing any type of a JOT validation. That is, in my later video, I'll be making more secure by creating a WAT on top of it, and make sure every request, right, it's actually signed, and we'll be doing some network wiring, so that all will be running the local with um more security layer on top of it, right? So those are all will be coming in my later video, but for now I'll just go with this value, the threshold value, which if it meets with the consecutive 3 frames matches, it will unlock the door. Let me launch the app. Okay, I'm just opening the web app, and this is the button I need to click to open my webcam, and the webcam captures the live video feed sent to the my backend system, which trying to check with the trained or like embedded model, which trained with my face, and try to validate the frame and try to create a cosine number which is greater than zero point 0.6 or 7 or 8, and if it's consecutive frames matches, it will unlock the door for me. Okay, it will make an 3 consecutive attempts. I'm on clicking the unlock with the face, and here you see it's dark, right? So it's not attempting, is getting 0 out of 3. Now I'm adding some light to my face. Now you see that the count is getting increased to 3. Okay, let me do it again. I think it passes the 15-second threshold, so it's failing. So let me do it again. Now I am pointing the light onto my face. Now it should work. Yep, it worked now. It door got unlocked. So that's it, guys. Thanks for watching the video throughout the end, and stay tuned for my next video. Thank you.